All right, welcome everyone. It's great to see so many of you are still staying at almost 5 o'clock in the afternoon on a Friday afternoon, not just any ordinary afternoon. Before I start, I would like to ask you how many of you have heard about WebAssembly? All right, most of you, that's great. How many of you have tried it out, like doing some stuff? All right, just 2 hands out there. Well, that's great, because today I'm going to show you a bit more about what is WebAssembly is and how it is related to what we already have on the web out there. WebAssembly is a compiler target for programs on the web. It allows us to compile from languages like C, C++, or other statically typed languages and run this into the browser. Its performance is very close to native, so it is very crucial to situations where we really need good performance in the browser out there. Furthermore, it allows us to reuse code. Suddenly we can take all our code bases written in C or C++ and just use it on the web, right? But let's see what's the current problem of the web right there. Well, today we have JavaScript, which has monopoly on the web, right? We do write JavaScript for everything. And if we take a look at this simple function out there, this is JavaScript function that adds 2 numbers, right? Well, not really, because JavaScript is a dynamic language, and although I am thinking about adding 2 numbers, these parameters could be anything. They could be strings, they could be objects, and the virtual machine has to take into consideration all these possibilities. And if you could say, well, if you're adding 2 numbers, then that's fine. But if you are not adding numbers, then maybe you're doing concatenation, right? If this seems reasonable, well, it's not really concise in terms of JavaScript, because when you start playing with different operators, we could get some really weird scenarios out there. And especially if you are trying to do some mathematical operations on the client, after debugging all day, it kind of really makes your head bump into all these issues that the only thing that could get you out of it is just some kind of drink in the afternoon, right? And this makes the whole JavaScript virtual machine very slow in terms of all these possibilities. So we have to optimize it in like different ways. Well, WebAssembly is a type language. We work with numbers only. We can have integers and floating points, and nothing else at this point of time. So if we have to take a look about how the previous function would look like in WebAssembly, it would be something like this. Well, WebAssembly is a binary language, so all these numbers, they represent exactly the same operations encoded with binary numbers. And although we are developers, we love seeing these kind of things, right? But it's very difficult to develop using numbers in this way, right? We prefer seeing some textual representations of our programs. Fortunately, WebAssembly comes with a textual version or textual representation. And if you're familiar with languages like Lisp, for example, this would seem quite familiar to you. So you could see we have our parameters, which are integers, and then the result is also an integer. So this is a typed language, so we know that every time a function is defined to accept integers, it will only accept integers or throw an error if you try to pass something different there. If we have to see how JavaScript is loaded today, we have to fetch the JavaScript file. And then because JavaScript is a textual language, so we have to parse it afterwards, and it takes some time. And then we go into this phase of compilation and optimization. I mentioned the dynamic nature of JavaScript, which makes the virtual machine trying to use some heuristics, some historical analysis of how your function performs. And if it sees that, okay, you're calling your function with numbers, it's returning only numbers, then the virtual machine can really optimize it and the function could run really fast. But once you break this prediction, then you start from the beginning again. So using all these heuristics or these predictions about performance, this is the way virtual machines usually optimize your code. And then you have the execution phase, and afterwards you have the garbage collection. If we have to see how the WebAssembly part will look like, then it's going to be something like this. We are going to fetch the WebAssembly file, which is a binary file, and then we are going to decode it. And decoding is faster than parsing. So already there, we are saving some time. Furthermore, because we have compiled to WebAssembly, so the compiler has already done quite a lot of optimizations to our code, then the next phase is also shorter. And we don't need to do any kind of predictions about the types, because we have types, we have integers. We know that our function is going to perform in the same way in terms of arguments and the result. And then we have the execution phase afterward, which is faster sometimes. At this point, we don't have garbage collection WebAssembly. So you could either port your own garbage collector or just reuse that's what the browser provides for you. So this is one of the further steps of development of WebAssembly. However, we can do even better than this, because WebAssembly comes with something called the streaming API. And because of the structure of the language, what we could do is we could download the bytes and start compiling it right away. So in some situations, you could end up, when your file is downloaded, the WebAssembly module, it's already compiled and it starts executing. So this thing can become really, really fast. WebAssembly allows us to create applications in a predictable manner. Because different virtual machines optimize your JavaScript in different ways, you can't really be sure how it's going to perform, let's say, on Edge or on Safari. Well, WebAssembly is a standard, so you know that the virtual machines, we're going to implement it in different ways. So you have some base of comparison with it. There is one guy who made a really nice 3D animation with some dancing robots. He uses WebGL for the rendering, right? But he implemented the code behind both in JavaScript and in C++, which he compiles to WebAssembly. And then he tried to measure the difference in terms of animation time. And the results are quite astonishing. According to his results, there is almost, you can see from 100 milliseconds down to 6-7 milliseconds from JavaScript to WebAssembly, which is a great improvement in terms of performance out there. WebAssembly is not only very fast, it's also another issue. Some years ago, you remember probably that when JavaScript was not that popular, when the only tool that we had was jQuery, we were used to program in other languages, and that's why we tried to reuse our knowledge in these languages and port it into the web. We tried to use Java applets, Flash, Silverlight, and it kind of worked for a while, but we realized that it wasn't really the way web was supposed to go. It made users download some third-party plugins, and they had to be updated. Furthermore, they introduced some security issues as well. So this was kind of problematic. WebAssembly is reusing code, and this is happening without the need to do something different. This is part of your virtual machine implemented in your browser. If you take a look at a traditional approach to distribute an app, so let's say you are building an app and you want to distribute it for all the operating systems. You have to build a version for, let's say, Windows, Linux, and Mac. But that's not that simple, because we are not only building for operating system, we are also building for a specific CPU instruction set on that operating system. So there are quite a lot of things that we have to do in order to distribute our app. With WebAssembly, we are using browser's virtual machine in order to distribute our app to the world. And besides that, you could also use Node.js, because, hey, we also have a virtual machine running there. So we could not only use the browser for the web, we could also use Node.js for the backend. If you are one of these guys having the misfortune to work with some legacy code, some very, very old legacy code, you have probably some solution that will help you. And if you imagine these big code bases written out there that are how to support, but still need it in some way, well, now we can reuse it, because if we compile them to WebAssembly, we can just use them as any other library. And this is, of course, both good and bad. So the tool is for you, and we have to see how we can make best use of it. All right, how are we going to produce WebAssembly? That's the question. Well, we are going to compile. We have our source code written in languages like C, C++, Rust, and then we need the compiler in order to produce the WebAssembly code. Afterwards, we need some JavaScript glue code in order to load WebAssembly afterwards, and then execute this into the browser. And there are many ways you could do this, but one of the easiest way to start with if you're using C and C++ is a tool chain called mscripten. Basically, it contains a lot of tools for you that allows you to compile directly from C and C++ into WebAssembly with some generation of JavaScript glue code for you. And if you start using mscripten, then the only thing you could do is using one command like this. This will be enough in order to get you started off. If you just want to play around with the compilation without installing mscripten on your machine, you could use WebAssembly, which is an online version of it's a one-line tool, which allows you to play around and write directly C and C++ code and see how the output will be, and you can download it and use it afterwards. And you can see, for example, you can see also the textual format, and if you think that it looks alike with what I just showed you, well, it should be 100% the same because I have copied it from here. And WebAssembly is distributed as module, right? We are developers and we are used to work with modules everywhere, and it makes perfect sense to continue using this here. Cool feature of WASM or WebAssembly modules is that they have imports and exports. So what we could do when you're writing your code in C and C++, you could require some external functions which we could inject from JavaScript afterwards, and you could export some functions which we can call from JavaScript. And this makes a perfect connection between your code and JavaScript afterwards. So this imports is just a JavaScript object where we could import constants or functions, and then we can export some functions that we can call later on from JavaScript. So how does it work? Well, we have our WASM module code, which we have to fetch, maybe using the fetch API, or in terms of Angular, you can use the HTTP client. Then we are getting an array buffer, and we are calling WebAssembly.instantiate, which takes the byte stream, and then you could provide the imports object if you want to import something. But if you work with Progress, or we are talking about progressive web applications where we are thinking more about the performance of our app, the load times, and things like this, caching, well, WASM modules, they are cacheable, so we can store them in something like IndexedDB, and then later on, especially if you're focusing on offline first scenarios, you could restore them from there. So there is a great opportunity for improving load times here. The question is, how can this help us? What's the place of WebAssembly in the world of web as we have it today? What is its relation to JavaScript and in frameworks like Angular? Well, we have to decide what we really want. WebAssembly is a tool, and I believe that there are two really big use cases where we want to use it. One thing is performance, places where we really need performance, and another thing is code reusability, basically plugging your code written in some other languages and using it on the web with the JavaScript together. So if we take a look at this simple architecture of an Angular application, what are our main elements? We do have components, we do have some directives, we do have some services, right? So one option could be, we could just create our own service, which is basically a wrapper of something that we have compiled to WebAssembly. You could think if we have SQLite written in C, then we can compile this to WebAssembly and then write a simple Angular service which exports the methods to insert into SQLite or read, etc. So this could be one option for that. And if we have to implement it, it's going to look something like this. Because we need to download and instantiate the WebAssembly, then in our service, we'll probably need to provide some kind of initialize method that we are going to call, and it's going to return either a promise or observable, something that will resolve into the future, right? And then we have to fetch and instantiate the WASM file, and then we can just call the functions on our WebAssembly module afterward from the component. So this could be one option, right? Another option could be that we integrate directly into the component. So if you want to modify the DOM maybe in one or another way, or interact with it, or provide any functionality that is more like UI related, we could just go directly to the component instead of creating this wrapper. Then it could be something like this. We have to instantiate it again. This could happen in on init, or just before calling your method, you could do this. And then you could call the methods afterwards. One thing we have to be aware of, though, is if we have some kind of callback, basically, where our WebAssembly code is calling us, we have to run this into ngZone. Because Angular, in order to determine that there are some changes to your model, it uses zone.js, right? So this part is not really monkey patched as the other asynchronous method. So we have to wrap this into an ngZone in order to trigger updates for our component out there. But what if we thought about something bigger? What if we rewrote the whole Angular framework in something like C and C++ and compile this to the web, which would perform much faster in some situations? Well, we could do this. There are certain problems with it, though. For first, at this point, WebAssembly doesn't have direct access to the DOM, which means that the only way to do this is we have to import some JavaScript functions that do this for us. And this means that there will be quite a lot of communication between WebAssembly and JavaScript. And although it is getting faster and faster, it adds some overhead to our overall application. So probably won't gain that much there, because Angular is already quite optimized according to the JavaScript virtual machines. But another thing is, I guess most of us are JavaScript developers. We like JavaScript. And if we did this, then it means that we had to start writing in C and C++. And although it may sound appealing for some of us, I don't believe that the whole community is ready to take this step. Although C and C++, they're great languages, by the way. But there is something we could benefit if we did this. Because if you are using frameworks like Ionic or NativeScript to compile to native on mobile, your code is going to be really fast because it's already written in a language that could compile to native directly, right? So we will have a great benefit in these situations. What if we could just take one of the libraries that Angular uses a lot and compile this to WebAssembly? This could be Zone.js or maybe RxJS. This could allow us to maybe isolate some piece of code and code this from Angular. But again, remember that these two will have to communicate over JavaScript, so there will be still quite a lot of communication between them. Or like if you take a look at reactive extensions, you could see these are the list of languages that the same library is implemented in all these languages. There are, of course, some difference in terms of functions, but the basis is really the same. Instead, what we could have done is just use the C++ version and compile this to WebAssembly and use it from all the other places. So we could have saved some time implementing the same thing in the different languages. I believe that JavaScript and WebAssembly, they can coexist together. And WebAssembly is not going to replace JavaScript, but instead is going to fix this parts where it's really weird to do things with JavaScript. This could be gaming, this could be virtual reality, this could be places where performance is crucial, where we need to reuse code to the web. So we don't really have to put WebAssembly into everything out there. So let's see some examples of stuff written in C and C++ and integrated with WebAssembly, how this could actually work. So I created this. The last couple of weeks I've been just experimenting. I created this simple website, and you could find the code on GitHub and things. And what I did, I grabbed the different libraries written in C and C++. I compiled them and integrated this into Angular components in order to demonstrate things like that. And I start with very simple one. Let's say everyone knows Fibonacci. So I created this very simple thing at all about a Fibonacci, where implemented both in JavaScript and WebAssembly. And you can see that in some situation JavaScript could be faster. So if you run this a couple of times, you could see that JavaScript could be fast in some situations. So it's not really always WebAssembly that it's really fast in that, right? And now it's thinking quite a lot, so there could be some issues with that. But anyway, and you could do some stuff from a library that you could, let's say, give some bitmap file, and then it will, of course, make some love out of it, right? These are just C and C++ libraries that I have compiled to WebAssembly and look like that. So I can do like this, and I can compile also OpenGL into WebGL, and because we're in ngVikings, we could also do like this. And this is running on my computer locally, so I don't really have access to the internet. Everything is, as long as it's downloaded, of course, it works locally here on my machine right there. And you could do stuff that takes a bit longer time. If you're a fan of cryptocurrencies, for example, then you could do some proof of work compilation here, where you could try to run this and see how long it will take. So if I want to calculate the second, it will take, if I put this to 3 leading zeros, it will take approximately half an hour to calculate this. So this is quite challenging. And the thing is that all I do here is that I'm calling WebAssembly and just getting the result. So if I have to show a bit of code, you can see like the Fibonacci component. This is my C version of it, where I have marked the function as external, which means that JavaScript has to provide this function. And what I'm doing is I'm just calling with some kind of text. And then I have exported the 3 different implementations of the Fibonacci number calculation. And I have exactly the same functions implemented in JavaScript out there. And if I go back to my component, you can see here that in onInit, I'm creating my imports. And besides some standard imports that we have to do, here is my function that I'm importing. And maybe you notice here that I'm doing some stuff with the result. Remember, I passed a string, but I told you in the beginning that WebAssembly knows only of numbers. So what I get here is actually a point into the memory. And the memory, this is, you can imagine it's an array that JavaScript gives to WebAssembly, and WebAssembly thinks it's a real memory, but it's not. It's just a JavaScript array, right? So what is happening is that this string gets encoded into this memory, and I have to decode it myself from JavaScript afterwards. And then here in the instantiate, when I instantiate my WASM file, then I can just call the exports and get the functions out there. And I can call them just normal functions and get the results after that. Great. The question is, how secure is WebAssembly? We had this problem with this Meltdown and Spectre issues, right? And it definitely caused some troubles for all of us writing some web code. And the cool thing is that WebAssembly is not going to be affected much. There are some stuff that were disabled, and if you know the shared array buffer, which allowed us to share some state, it caused some issues, so it got disabled by all the browser vendors. But the rest is there. And the reason for that is that WebAssembly reuses all the security architecture, all the security measurements that we have implemented for JavaScript. It lives in the same sandbox. So it can't get worse than that. We don't have real access to the file system. We don't really have access to the real memory. We have access to JavaScript objects. So what if you can do harm with JavaScript, you could also do harm with WebAssembly. What's the status of WebAssembly? Well, it is already there. It's implemented in all the major browser vendors. And the state of WebAssembly now is called MVP, a minimal viable product. So you can go and take something written in C and C++ and compile this, and it is going to work in Edge and Chrome, Opera, Safari. I'm using, by the way, Edge, which is normally one of the browsers that the things don't work in, but WebAssembly works pretty fine in it, as you saw right there. And another interesting thing is what can we compile to that? And I mentioned I've been talking primarily for C and C++, but ladies and gentlemen, I want to present you the wheel of WebAssembly. And what it does, it's almost like the Wheel of Fortune. You get some random numbers between 1 and 100, and each of these parts, it's a compiled version from the language that is stored there. And each part, it's loaded completely independently. So each part defines its name, and it provides me a function that I can call and return a number between 1 and 100. Unfortunately, you don't get anything to win, but you could just spin it as many times as you want and get numbers from the different languages out there. And of course, most of these languages, they have experimental support. The strongest support is for C, C++, and Rust. But still, many languages, their compilators, they get also a WASM version, which is really cool because suddenly it shifts all this think about writing only in one language into reusing code in general on the web. What's the next? I mentioned that the current version of WebAssembly in the browser is MVC, is MVP, right? It's minimal viable product. But we need direct access to the DOM. We need direct access to the web APIs that we can call directly from WebAssembly instead of wrapping this in JavaScript. We need better interoperability between JavaScript and WebAssembly. This is coming because the community is great and people are working on that. We also need to work onto the garbage collection, because at this point, especially if you're writing games, you really want to be able to manage your memory yourself, right? This is not really possible at this point unless you port your own garbage collector to the WebAssembly, but then your application, of course, grows with all these additional libraries that you have to put there. There was an idea of multi-threading, which would be really cool, but with these security issues, I think this is not going to happen anytime soon until we fix the problems with Spectre and Meltdown and the security gets better in terms of that. I believe that WebAssembly changes really the way we think about web. Suddenly, instead of re-implementing everything in JavaScript, we could reuse code by compiling to JavaScript. And if we can do this compilation, if we have the right tools, we would be able to make really great usage of all the code that people write in any kind of languages and just focus on doing what we really do. And this is to design great apps and to solve everyday problems. Thank you so much.